When we think of stars, we often picture tiny, twinkling lights in the night sky. This is how we perceive them from our vantage point on Earth. However, stars like Betelgeuse are quite different. Betelgeuse is one of the largest known stars, vastly bigger than our Sun. For years, scientists have been fascinated by Betelgeuse, but recent developments have raised concerns. Something unusual is happening with this star, leading researchers to worry. Physicist Michio Kaku describes Betelgeuse as a colossal wonder, a star that has intrigued astronomers for many years. It was first identified by a Greek astronomer named Ptolemy. Betelgeuse is so massive that it can be seen from Earth, especially during winter. If you're interested in astronomy, you may have heard of it. It's the reddish-orange star marking the upper left shoulder of the Orion constellation. Betelgeuse is one of the brightest stars in the night sky, but its brightness fluctuates. Most stars are extremely distant from Earth. The nearest star, Proxima Centauri, is 4.2 light-years away, an immense distance. To put that into perspective, traveling at the speed of light, about 186,000 miles per second, it would take a year to cover 1 light-year. Betelgeuse, however, is about 600 light-years away. Despite the distance, its sheer size and luminosity make it visible to us. Betelgeuse is approximately 500 times larger than the Sun, with a radius about 1,000 times that of our star. Advanced telescopes reveal Betelgeuse as a disk, not just a point of light. Its mass is estimated to be 12 to 19 times that of the Sun, but scientists can't determine its exact mass due to the absence of planets orbiting it. Despite its enormous size, Betelgeuse is much cooler than the Sun, with surface temperatures of around 3,500 Kelvin. A remarkable feature of Betelgeuse is its dark magnetic spots, which are much larger and more numerous than the Sun's sunspots. The magnetic fields in these regions are much stronger, preventing hot gases from reaching the surface and making Betelgeuse cooler in those areas. Some of these spots can be twice the size of Earth. Betelgeuse also has a magnetic field about 1,000 times stronger than the Sun's, which causes its surface gases to form loops or arcs, observable through telescopes. Another striking feature is its reddish hue, although it wasn't always red. About 100,000 years ago, it was yellow, like our Sun. Over time, it transitioned to orange, and now it appears red, signifying that Betelgeuse is aging. Despite being 600 light-years away, it emits 100,000 times more energy than the Sun. If it were closer, it would dominate the sky, and if it replaced the Sun, it would engulf Earth and several other planets. Known as Alpha Orionis, its size is one of its most striking characteristics, with a radius about 1,000 times larger than the Sun's. This means that if Betelgeuse were placed at the center of our solar system, it could encompass the orbit of Jupiter. Despite its size, Betelgeuse is not the most massive star, with estimates of its mass varying from 12 to 19 times that of the Sun due to the challenges in measuring stars without nearby companions. The star's luminosity fluctuates irregularly, ranging from magnitude +0 to +1.6. At its brightest, Betelgeuse is 16,000 times more luminous than the Sun. These fluctuations are due to its pulsations, which cause it to expand and contract. When it expands, it brightens; when it contracts, it dims. These cycles can last anywhere from days to months. Betelgeuse is in the late stages of its life as a red supergiant, having exhausted the hydrogen in its core and now fusing heavier elements, causing it to expand. Its atmosphere contains large magnetic spots that block hot gases from rising, resulting in cooler regions. These spots are much larger than those on the Sun, and studying them helps astronomers understand stellar magnetism and the behavior of massive stars. Betelgeuse has held cultural significance throughout history. Various civilizations, including the Greeks, Egyptians, and Chinese, have observed and documented it. In ancient Arabic astronomy, its name means the hand of the giant, reflecting its prominence in the Orion constellation. Despite its ancient origins, Betelgeuse continues to fascinate scientists today. In late 2019 and early 2020, Betelgeuse underwent a dramatic and unexpected dimming, sparking widespread interest and speculation. While Betelgeuse normally fluctuates in brightness, this sudden and significant dimming was unprecedented. It led many to wonder if the star was nearing the end of its life and preparing to go supernova, a spectacular explosion marking the death of a massive star. A supernova occurs when a star exhausts its nuclear fuel. Throughout its life, a star maintains equilibrium by balancing the outward pressure from nuclear fusion in its core with the inward pull of gravity. In stars like Betelgeuse, nuclear fusion creates heavier elements such as carbon, oxygen, and eventually iron. Once the core is mostly iron, it can no longer generate the energy needed to support itself, causing the core to collapse and resulting in a catastrophic explosion known as a supernova. If Betelgeuse were nearing a supernova, it would be one of the most significant astronomical events ever witnessed. Supernovae are rare, with only a few occurring in our galaxy each century, making them important scientific milestones in the life cycle of stars. The explosion of Betelgeuse would release an enormous amount of energy, potentially outshining distant galaxies and illuminating the night sky with unprecedented brilliance. Located around 600 light-years away, Betelgeuse is already one of the brightest stars in the night sky. If it were to go supernova, its brightness would increase dramatically, possibly becoming visible during the day, something that has not been seen in recorded history. The explosion would be so bright it could outshine the full moon and cast shadows on the ground during the day. For astronomers, a nearby supernova would provide a unique opportunity to study the final moments of a massive star's life. Observations could reveal valuable data about supernova processes, the formation of neutron stars or black holes, and the distribution of heavy elements in the universe. Supernovae are critical in enriching the interstellar medium with elements like carbon, oxygen, and iron, which are essential for the formation of planets and life. The potential cultural and psychological impact of witnessing a supernova should not be underestimated. Throughout history, celestial events have inspired awe and wonder, influencing art, literature, and science. A Betelgeuse supernova could rekindle curiosity about our place in the universe, encouraging interest in astronomy and science. People would gather to witness the event and share their experiences, engaging in discussions about the cosmos. The possible daytime visibility of a Betelgeuse supernova could also lead to intriguing cultural interpretations, as ancient civilizations often viewed celestial events as omens or messages from the gods. Such a phenomenon could reignite these discussions and potentially alter cultural narratives surrounding the cosmos. While the excitement over Betelgeuse's dimming event in 2019 and 2020 sparked speculation about an impending supernova, recent research has suggested otherwise. In mid-2020, astronomers concluded that the dimming was likely caused by a massive dust cloud, formed from material ejected by the star, temporarily blocking its light. This discovery eased concerns that Betelgeuse was on the verge of a supernova. While Betelgeuse will eventually end its life in a supernova, it is unlikely to happen within our lifetimes. Estimates range from a few hundred to a few thousand years. Nonetheless, Betelgeuse's proximity